Hello, ladies and gentlemen, and welcome to Lesson 7, Atomic Structure, Part 1. This is the last lesson of this booklet, so we'll finish it off strong. So as you should be used to by now, we start every lesson with a knowledge check. So I would like you to write down the answers to this knowledge check either in your digital copy or on a piece of paper or in a paper copy. That will be fine. And then pause the video and we'll come back for the answers in a moment. So at this point, you should have unpaused the video and have all your answers ready to go. So going through, if you have another colored pen, that's great. If you don't, that's fine. Correcting any answers that need correcting, and otherwise just ticking off the ones that you already have correct. Well done. So state the charge of an electron. An electron has a charge of -1. Yes, the 1 is important. It isn't properly correct without it. If you've done it in symbols, such as here, that's fine as well. The charge of the nucleus is positive. We don't have a number for the charge of a nucleus because it can be anywhere from +1 to +100. Because it varies, we don't include the number. We're looking for the definition of atom, so we want what that word means. So we're looking for the word indivisible. Or if you said it cannot be divided, it can't be broken down, that's fine as well. The subatomic particles found in the nucleus, we have the proton and the neutrons. The subatomic particles we find in the energy levels, we have the third one left, and those are the electrons. The capacity of that lowest energy level, we can only fit 2 electrons in the lowest shell. The charge on a proton is +1. Again, if you've used symbols, that's fine as well. And the charge on a neutron is neutral, or it has no charge. So, as I said before, this is the last lesson in this booklet. So we're taking everything, wrapping it all up, and putting it all together that we've learned the last several lessons. So hopefully you remember that we have energy levels where the electrons sit in the atom. So we fill those energy levels up, as you might remember from the last video, from the inner energy level to the outer energy level. So we always start with the one closest to the nucleus, which hopefully you remember can hold 2 electrons, and then work our way out from there. So each energy level does have a maximum capacity, which means it can hold no more than that amount of electrons. So we've talked very extensively on the fact that our first energy level can hold 2 electrons. It's not a coincidence that the first period of the periodic table has 2 elements in it as well. If we move down the periodic table to the second period, we have 8 elements, starting with lithium, ending with neon. So we have those 8 elements. The second shell of the atom can also hold 8 electrons. This is part of the genius behind Mendeleev and the way he designed the periodic table, that this is all able to work as well as it is. So period 2 has 8 elements, and the second energy level has a capacity for 8 electrons, and so on. So if I say there are 8 elements in the third period of the periodic table, how many electrons would you guess would be in the third shell of an atom? If you said 3, well done. So you will remember 2, 8, 8. This is what you need to remember to fill up those shells. So 2 is the first shell, 8 is the second shell, and 8 is the third shell. We do occasionally use the fourth shell when we're talking about the first 20 elements, so just for potassium and calcium. But if you look on the periodic table, you'll see there are 18 elements in the fourth period. So how many elements do you think might be in that, can fit in total in that fourth shell? Yes, it is 18. But you only ever need to put a maximum of 2 in there, but it can hold more than that. So these 2 videos here, which hopefully you should be able to click on through your digital copy of the booklet or your teacher has sent through for you, explain this in a little bit more detail, a little bit more clearly. So go through, watch those 2 videos, take some notes as you're watching them so you can refer back to them if you need to. Once you finish that, I would also like you to re-quiz yourself on those first 20 elements, so hydrogen through to calcium, just to make sure that they're fresh in your mind because we will be using them later on. So you can do that either by a look and cover technique, you could be doing that, you could ask someone in your household to quiz you on them, or you can find a quiz online, and there's a couple that are even games and things to help you remember those first 20 elements. So pause this video, watch those 2, quiz yourself on those first 20 elements, and then come back to this once you finish that. All right, so zooming in even more onto an atom and how it's set up. So we know that all atoms have an overall neutral charge, which if you remember, means they have an equal number of positive charges to negative charges. So if they had, for example, 5 positive charges, they'd also have 5 negative charges within the atom. So we know in an atom, those positive and negative charges are protons and electrons, so they have the same number of protons and electrons. We often say that those charges cancel each other out, or we say the charges are balanced, are 2 ways that we sometimes talk about that fact. The periodic table, you might have noticed, has numbers for each of the elements. These numbers show us how many protons, electrons, and neutrons each atom of that element has. So remember that the atoms are very, very, very small, and there's billions upon billions of them in each and every, in anything that you're looking at, but each individual atom has the same number of protons in that atom. So this will become easier to do if you have a periodic table in front of you. So even if you just open one up in another tab so you can have a look at one when you need to, that might be handy. Or if you happen to have one printed off, even better. So you'll notice in each box there are 2 numbers. We have our atomic number and our mass number, or atomic mass is sometimes what it's called as well. So the atomic number is the smaller number. Depending on which periodic table you're looking at, sometimes it's the one on the top, sometimes it's the one on the bottom. But it will always have a key to tell you which one is which, if it's the one on the top or the bottom. It is also always the smaller number. So if you're looking at one element, for example, let's use boron. It has, the periodic table I'm looking at has 11 on the top and 5 on the bottom. So because 5 is smaller than 11, I know that 5 is the atomic number, which means that 11 must be the other number, which is the mass number. So our atomic number for boron here, our 5, is equal to the number of protons. So you'll notice every single element has a different atomic number. This tells you the identity of the atom. So if the atom has 5 protons, it will always be a boron atom. If it gains an extra proton somehow, it becomes a carbon atom. If that boron loses a proton, its atomic number changes to 4 and it becomes a beryllium atom. So it's the number of protons as well as the identity of the atom. So we also know that the number of protons has to equal our number of electrons, because we know that atoms have an overall neutral charge. So if boron has 5 protons, it must also therefore have 5 electrons as well. So we know the number of electrons because of the number of protons, which is the same as the atomic number, which is the smaller number on the periodic table. So we said the 11, the other number, we said is the mass number. So that tells us everything in the atom that has mass. You might remember from a previous video that we've talked about the fact that the protons and the neutrons are both really heavy, comparatively, and the electron is so light it has no mass. So the mass number is the total number of protons and the number of neutrons, or the number of subatomic particles in the nucleus, because we know protons and neutrons are in the nucleus. So if we think about it, we have our mass number of 11, so we know something plus something equals 11, protons plus neutrons. We know we have 5 protons, so 5 plus blank gives you 11. With your maths, you can figure out that we have 6 neutrons in boron. So we can always figure out the number of neutrons, not from looking directly at the periodic table, but we do have to do a little bit of maths. The number of neutrons is the mass number, which we always know is the bigger number. Subtract the atomic number, which is the smaller number. I know this is really confusing, and often it helps to go over it a couple times, so I'd like you to watch this video here as well and just give it a go, just to have another sense of it and to make sense of it, because this is important and it can be very confusing, I know. So here are a couple more examples. It includes boron, the one we've just done, but we also can look at helium. If you look at helium on your periodic table, you'll see there's a 4 and a 2 in the box. 2 is the smaller one, so that one must be the atomic number, which means it has 2 protons, and as well it has 2 electrons. If 2 is the atomic number, 4 must be the mass number, and in order to get our number of neutrons, we have to go 4, take away 2, which gives us 2 neutrons. The same is true for the other elements. So here are a couple more examples for you to have a look through and give a go. So now this is where the revision of the periodic table and having a periodic table will really come in handy. So you're going to go through all of the different elements. If you don't have the digital copy of this and you just want to write the table out as on paper, that's totally fine. So you're going to go through the different elements. You're going to write down the symbol. This should be easy enough for you to remember how to do. So for example, let's do helium. Helium, I know the symbol is He. Remember that it's always a capital first letter and a lowercase second letter, if there is a second letter. I look on my periodic table and helium has a 2 and a 4. So I know 2 is my atomic number, which is my protons. All right, so my atomic number is 2. My electrons I know is equal to my protons. So I know for here, my electrons must also be 2. And my neutrons I know is my mass number. Take away my atomic number. So it is 4, take away 2, which is equal to 2. So that all makes sense. So if I were to now go on and look at nitrogen. So nitrogen, they've put the symbol in there for me already. I look on my periodic table, there's a 7 and a 14. So 7 is the atomic number, so that's the number of protons, also the number of electrons. Those two numbers make sense. My number of neutrons is my mass number, take away my atomic, so it's 14, take away 7, which gives me an atomic mass, or a number of neutrons of 7. So now I'd like you to go through giving all of these a try, all the way from element 1, hydrogen, all the way through to the 20th element, calcium. which is why you have to quiz yourself on the first 20 elements. So pause the video, give it a go. We'll go through all the answers in a bit. All right, so I finished the table here. So have a look through, make any corrections that you need to. And there's a couple things I'd like you to notice. Hopefully you were looking for patterns as you were going through to make it a little bit easier. And you probably noticed that the number of protons just increases by 1 every time. So hydrogen has 1 proton, helium 2, lithium 3, beryllium 4, boron 5, because the atomic number increases by 1 each time. The same with the number of electrons, because we know that our electrons are equal to our number of protons. The number of neutrons, however, doesn't have as easy of a pattern. And that's because different atoms can have different numbers of neutrons, and we call those isotopes. So an isotope is when an atom has the same number of protons. So it's the same element, but it has a different of neutrons. So for example, we might have a sulfur atom that has 17 neutrons and one that has 18 neutrons. But the one that has 60 neutrons is the one that we find the most in nature. And we're not 100% sure why that is, that we find that one the most, but it is just the one we find the most. And so that's why we say sulfur has 16 neutrons, because that's the one we find most often. And so that's what we go with, just to keep it simple. So you might have noticed that chlorine, the mass number for chlorine was actually 37.5, because we find both the isotope for either side in equal amount. But that's not something we need to worry about just yet. You will learn more about isotopes later on. But that's why there's no pattern in the neutrons. So hopefully you've had a chance to get all of that data down. If you've missed something, just pause the video, make sure you have the correct answers. One more thing I do want you to notice is that there's always a capital letter first and a lowercase letter second if there's a second letter. That is important. That's a really silly mistake to lose on an exam, because if you were to write it, for example, calcium, capital C, capital A, capital C, capital A, you would lose the mark for that question, and that's a silly reason to lose a mark. So, based on what we've just talked about, I'd like you to give this checkpoint a try, and then also the knowledge and application check. There's 8 questions here and 3 more on the next page, so use your digital copy to go through it. Once you have that all in, start the video again and we'll go through the answers. Let's now have a look at the checkpoint answers as well as the knowledge and application check answers. So starting with A, give the number of electrons in atom W. So atom W, it doesn't actually stand for something, but it's just a placeholder they put. So if we know it has 16 protons, it must also have 16 electrons because it is in atom. Give the atomic number for atom X. We know that the atomic number is equal to the number of protons. So X has 17 protons. So question B, the answer is 17. The letter of the atom that has the greatest mass number. So we know that our mass number is our protons plus our neutrons. And if you add up protons plus neutrons for each of them, you'll find that Y, so for question C, the Y has the greatest number of protons plus neutrons, so it has the greatest mass number. And for D, the letters of the two atoms that are isotopes of the same element. So as I said, has the same number of protons, but a different number of neutrons. So you'll see that X and Z both have 17 protons, but a different number of neutrons. So X and Z as our answer for D. And straight into the knowledge and application check. If you haven't finished it, pause it now, give it a go, and come back. So the subatomic particles we find in the nucleus are our protons and our neutrons. The subatomic particles we find in the energy levels are the electrons. The capacity of the lowest energy level is 2. In our second energy level, or second shell, we can fit 8. The overall charge on an atom is neutral. The two subatomic particles that make up the mass number is protons and neutrons, the same as in question 1. So hopefully you'll be able to remember that more easily because of that. The smallest subatomic particle is the electron. Why an atom has an overall neutral charge is because our protons is equal to the number of electrons. And so they cancel each other out, or they balance each other. And then on the next page, 3 more. Why adding lots of electrons makes little difference to the overall mass of an atom is because the mass of an electron is so much smaller than the protons or the neutrons. Why do atoms have an overall neutral charge? We've already answered that question. And why do electrons orbit the nucleus? Because they're attracted the electrostatic force, because we know that the positives and the negative have that attractive force between them, that electrostatic force. So there are the answers for that. If you have any questions about this lesson, don't forget you can always email your teacher for more help, or you can email the science department email address as well. If you have tried the extension activity and would like some feedback on that, or feedback on anything that you have done, feel free to send some pictures to your teacher or to the science department email address in order to get any feedback from that.